Right, there you go. You want to share your screen? Should now work.
Am I not sharing already? Can you see something?
Oh yeah, I've got your camera up. Yeah, you have to share screen on the left. The green.
Yeah.
Yeah.
Okay. The slide. Right, so this is Pina, where I'm from in Italy, from Verona. And it's similar to the Colosseum, but it's much better for me things about it. It was built around the 1st century, more or less, by ancient Romans. Rich people at the time, high demands, they wanted to go see people kill. So they said, okay, let's build something like the Colosseum, but let's build one here. They built just this first inner circle initially, and all the rich people could go there and see people kill each other. Not so rich people were like, hang on a second, we want to join in the fun too. We want to go and see the show as well. So what they did is they added another circle, the top one that you see, to fit more people in. We're like, hang on a second, everybody is going there to have fun, so we wanna. So they built a 3rd layer around. That 3rd layer was actually destroyed by an earthquake in the 12th century, and all there is left is this top. But so in the 1st century, these guys managed to build something incrementally with each release, deliver the most value with the first release, and even if a piece of it fell down intact and it's still in use nowadays. Usually we don't kill people in there anymore. It's mainly used for concerts nowadays. A lot of the season was having One Directions there. I wasn't there. Bit of One Directions. I'm originally from this town called Verona. You might know it more for Romeo and Juliet, possibly. By the way, Romeo and Juliet is all fake. Don't go there if that's why you're going there. I work for SNS. I don't know if you've heard about us before. We are the guys in doing everything to do with telephone, broadband, and soon mobile as well. With today at Sky that we did our first mobile call. So who they called, but they did it. Yeah, over there I help teams with agile, all sorts of things, but about something technical actually. In my team, we used this thing that Unclebob called. We used it for a couple of applications. Frustrating to find real examples when we were trying to understand how it works. Let's share our experience that we did it, and hopefully you will find it interesting and see if it applies to you. Before I go forward, I know all the cool kids around are doing microservices. This talk is not really about microservices. Not because we're building monolith, obviously, we're not building monoliths anymore. What I'm talking about is still the architecture just of an individual application. And I guess they say microservices should be so small that, well, doesn't really apply to something that small. But I'll come back to this point later on. And obviously, this is just my experience and the experience that my team had with this. I don't claim it's the one way to apply it. It worked for us, and it had lots of benefits. Now, everybody just saw the pizza coming in. I'm not sure if you want to grab food whilst you're listening, or... Yeah, I wouldn't keep you away from the food. You would hate me. So I guess we can just pause for a minute and let you get food. Yep. And then when you're comfortable again, we'll carry on. Yep, go for it.
Yeah, big one, I remember that.
Oh.
I went to we went
Oh,
to
yeah.
It's nice.
Yeah.
Lovely town.
It's a lovely town.
Yeah.
They really try to make money on tourists with all the European tourist stuff. Yeah. People love it.
I think it's like watching the river. It's like a bridge with like a really fast flowing river going through it.
Yeah.
You can sit up there.
Who wants veggie? This is the one.
Process can be parallel. Did you come to us today? Yeah. Yeah, a bit of a track, isn't it? Yeah. Yeah. Okay, yeah. So it is a bit of a mission to get here from. Yeah. It's nice. Yeah, not certainly changes. You guys going to be staying back? You're not going to be moving to New Zealand?
No.
Not as far as you know. Yeah.
Moving to a new office.
Oh, really?
But you never know.
How many people are there? I wasn't thinking about it.
We chose. Almost more. Yes, yeah, we only have a couple of floors. We were only down the road, but
Yeah.
we didn't get to be demolished. So they could,
Yeah, is it a nicer office? Oh, really?
nice location. You see how we
It's nice because it's a whole campus and everything's here. Yeah. That's pros and cons.
Wow. That's holding us. Do you get events like this quite often around here?
Yeah.
That's nice. Almost better than this group. Sorry? Occasionally, but not so often because there are so many people. So, yeah, it's difficult to find someone with something new to talk about. We have planning talks every now and then. We run back sessions. For us to come over here and have something else. Oh, that's okay. So if at any point you need to walk around and grab more pizza, feel free to do it. I'm Italian, I know that pizza is priority. So I was saying that today I'm really talking about how we use this architecture for building and design application. And there is a list of problems that I see people having again and again and again. We tend to take decisions way too often about our architecture, about our technologies. We say things like, oh, we need to lay the foundations of our application. And this is usually at the beginning of a project or when we're starting an application, and that is when we know the least about the requirements that our application needs to fulfill. This usually leads to things that are hard to change. We have committed to those decisions, and when we discover new requirements, new things that our application needs to be able to do, we're like, oh crap, what do I do now? My application wasn't meant to be doing this, so do I hack it in or do I go through a painful redesign and do it properly? And we all know which option wins usually, because our decisions that we took initially are quite often hard to change. Often because we center our applications around frameworks. We decide a bunch of technologies, a bunch of frameworks to use. We might even commit to a particular vendor, build our application around it. We have to follow the quirks of that particular framework or how the vendor wants us to build something. And we become what Unclebob calls slaves of that particular framework. Or even more often, we center everything we do around the database. A CRUD system with a fancy GUI. And all you do is create, read, delete, and update your entities. This is especially common when you end up using your Hibernate objects everywhere as your domain, or your tables first, and then you build an application around it. We as developers are particularly bad at this. We tend to focus on the technical details, the technical aspects of what we do. When you look at your packages, you see something like controllers, views, focusing on the domain aspects of our applications, which makes things quite hard to change because quite often the business logic is spread everywhere. We're doing some logic, and then a service is rearranging something. But then, you know, in the JSP, you've got a little if that has to make something look nice. So you've got business logic across all layers of your application, which means you need to read all your code to understand what's going on. We very, very often see people with slow, heavy tests, hard to test applications that have to be tested through Zoom or spinning up the whole application and doing black box end-to-end tests, which leads to slow builds and, in particular, infrequent deploys, because if you have a slow build, you tend to deploy less often. Those things are so hard to change. We tend to be scared of doing changes, so we end up doing feature branching. We create long-lived branches, mess around with everything we want without worrying about breaking stuff. Actually, we'll merge it, which leads to less and less deploys. I'll expect you might have experienced at least some of these problems, even other problems possibly. I'm not claiming that clean architecture is a magic bullet that is going to solve all of them for you, but it made them a lot for us, at least. It doesn't solve them completely, maybe, but it really helped us with all these problems. And it did so by following a principle from Unclebob, which sounds simple when you read it, but it's actually really powerful. And it's best explained with this quote from him. So let me read it out for you. The center of your application is not the database. One or more of the frameworks you may be using. Center of your application is the use cases of your application. I've highlighted the second part because that's really the key. Application is the use cases of your application. As developers, we tend to focus mostly on those things, the top half. Well, don't get me wrong, it's important. We have to make things work at the end of the day, but that's not really what we get paid for. We don't get paid to, as developers, we get paid to solve business problems. That's writing code. What I try to get my team to do with this type of architecture is to focus on this second half, the business problem, to focus on the use cases of the application to make everything work. But those are the technical details. Unclebob started to talk about clean architecture around 2011, 12, and formulated his thoughts in a quite famous blog in 2012. Diagram. It's not particularly easy to read, and I'll explain better with other diagrams. To quickly explain it, you've got entities at the center, which represent your domain objects, and use cases around which represent all the use cases, all the things that your application can do. On the outside, you've got all the what he calls details about whether you're doing a web application or a GUI or a database. Some part of this diagram are these little black arrows, and they all point inwards. They represent dependencies. This means that I have no idea what use cases are using them, and even more importantly, idea whether they're being used from a web application, from a command line application, or logic. That's it. No, it's not it. This was my problem when we started to look at this type of architecture. We read this blog and we're like, oh, this is so cool. How do I implement it? There are 100 different talks of people that usually stop here, and they tell you all the theory, but you're left with like this for real. So what I did is I took one of our production applications, removed all the information, all the stuff that shouldn't be public, and it's on my GitHub under a clean architecture example. So you can have a look later at all the details of how it works. Example throughout the talk. It's an example of what we do at SNS, actually. So we, in particular, deal with keeping track of all the assets that Sky has around the exchanges in the UK. In case you're looking at the examples, how exchanges and devices are inside an exchange, and the use cases that are built into the example are: have I got capacity in a particular exchange? So can we sell broadband to more customers in this particular area? What do I know about these devices? Do I have up-to-date information? Parties need to get the details of particular devices. So here is our architecture works for one of our applications. This thing called core at the center, and core contains entities and use cases. Entities are very simple objects that represent our domain. So you can expect to find an object for exchange, an object for device, all the things you need to represent your domain. Use cases. Use cases are the things that our application can do, or the requirements that our application fulfills. That is where you can expect to find all the business logic. In order to do that business logic, they usually need to retrieve some data, or change the state of some data, or talk to external services, do stuff. They do that through these interfaces. So these little red boxes, they define interfaces of what a use case might need, implemented by these guys on the right that we call data providers. In application, we have something like 10 of base data provider to retrieve and store data in a database, to actually talk to real devices, a bunch of data providers to talk towards external systems, third-party systems. What they do is they implement interfaces so that a use case can retrieve data and store data. But the use case has no idea who is triggering it. And that's the job of the entry points. Guys that let you interact with the application. We've got some REST APIs, jobs. If you had a GUI, it would be here as well. But all they do is take input something, for example, get an HTTP request in input, somehow validate the input, but then all they do really is and convert the result back to whatever client is calling them. A REST API would convert into JSON and return something. A scheduled jobs would simply results of what happened probably. If you had a GUI, you will probably implement MVC in your GUI, would call a use case, and convert the results to thing on a web page. At the bottom, the last piece of the puzzle is this thing that we call configuration. This is where we hide all the dirty details about objects together, where our main class is, where we try to relegate the frameworks so everything is hidden in there, isolated, and nothing else knows about technical details. If you prefer Unclebob style, here it is. You've got entities and use cases at the center, entry points and data providers that use the use cases, and the configuration around that keeps everything together. Is anyone not using IntelliJ? Okay, cool. So you probably understand what's going on here. This is what the project looks like in your IDE. Under application, we've got 4 modules, one for each one of the things that I described. and then acceptance tests and integration tests that I will talk about in a second. It's important to notice that these are modules, not just packages. And that really made the difference for us, because with using modules, you can really enforce the separation of concerns between the different layers of your application. The core, for example, doesn't depend on any library, doesn't depend on anything else, because we want pure business logic in there. So if you try to do something in core that you're not meant to, it doesn't compile. So we like to say that using modules makes it hard to do the wrong thing. Just very quickly show you examples of what each one of these components look like, starting with entities. So we are in core under a package called entities. You will find one object for represent our domain. These are simple POJOs, simple Java objects, framework or library in here. They are just representation of our domain. So an exchange has a bunch of fields, getters and setters. A device has fields, a reference to the exchange it's in, getters and setters. We like to use tiny types when possible to try and have a stronger typing system. Up to you, is nothing to do with clean architecture. I've already told you all these things, but they are in the slides in case you're reading them later. Now, use cases are a lot more interesting. In the use case package, we try to follow our domain terminology. So when you open the package, you immediately get an idea of what you can do in this application. For a broadband access device, I can either get the details or reconcile them. And for an exchange, I can get the capacity of the exchange. This is what people call a screaming architecture. It's something that just by looking at the package structure of the intended usage of your application. It's not about the technical details of the application. It's about what your application can do, what the domain of your application is. And this is what a use case looks like. We've got some references to data providers that we're going to need. Public method to get the capacity for this particular exchange is fail if exchange does not exist. So we ask a data provider, does this exchange exist? Now, I have no idea where this is happening. This could be a query, third-party system that tells us if the exchange exists or not. We could be calling a real network device. I don't actually care at this point because it's not part of. But if the exchange doesn't exist, I throw an exchange not found exception. This is a business error, and I have no idea what this will look like for the client. If this was coming through a REST API, this would be converted into a 404, but page, it would be converted in a red message on a web page, potentially. If the exchange exists, we do a bit more logic. We find all the available ports and an object to describe that there is capacity in this exchange. Can we sell ADSL and can we sell fiber? Maybe one day we will sell mobile as well. So the use case does all the business logic and defines the interfaces that it needs. So it defines that it needs to know does an exchange exist, and it needs to retrieve all the available ports. But we don't know about who is going to implement this. By the way, we like to use single method interfaces for keeping the interface segregation, but again, that's just another little thing. The data providers are the guys that will implement those interfaces to requirements. I be able to retrieve something from the database or from a network device. As we implement the interface twice, because we might have caches the result of something in an implementation that something. But what's nice is that the use case has no idea where the data is coming from. In the example on GitHub, you will find a database implementation and a network implementation that talks pretends to talk to a real device. But all that a data provider does is it interfaces to do the stuff that the use case needs. This is what a database one will look like. Some queries using JDBC template in this example, but which is that data providers are in an isolated module, so I could use whatever framework I wanted in here, and no other part of the application would know. You see template, you can use Hibernate, JPA, whatever you like. For something like JPA, though, I wouldn't use the entities directly, but I would create a new copy of the objects in here, the database representation of those objects, to change my domain to fit the table. This is something that, if you're familiar with DDD, with domain-driven design, is called bounded context. Bounded context, and for each different module, I want the best possible representation. Trying to do. That's just another example, don't worry. Entry points are what we use to interact with the application. APIs and some scheduled jobs that run regularly. You could have a GUI as well here, a mobile client possibly. All they do really is, as to the use case that we need. This is a REST API example. This method is annotated to, well, it's using Spring Web to do some REST stuff. Spring Web is isolated only in this module. All it does is call the use case, convert the results to the DTO that we need to return to our client. Wrong, and we had some business error. Somehow convert that error into what makes sense for our client. So this business error will be converted into which is a 404. Job does exactly the same. We have a reference to the use case, put the use case, and just record the results somewhere or somewhere, so that morning we can check what the scheduled job did. Password configuration, our main class. All the configuration that we need to add a strong configures web server, what we need for the application to run. We try to reduce the boilerplate to a minimum using Spring Boot. If you're familiar with Spring, you might recognize this sort of things. All we're doing really is creating the objects and wire them together. What's nice, again, is that configuration is an isolated module. Only this module knows that we're using Spring for dependency injection, having Spring everywhere in our application. That's the problem with people using Spring. It ends up spreading everywhere, and you become tightly coupled to Spring. It's isolated in here. We could easily replace it with something else, or just by instantiating everything by hand. What does it look like altogether? Let's say that you live in Chelsea and you're going to the supermarket, and you have those annoying Sky people trying to sell you Sky. use something that eventually calls one of our services in SNS to find out what can we sell to this customer. Ask one of our services, get me the capacity in this particular exchange in Chelsea. So one of our REST entry points would receive this request and call a use case. Would find out if we have capacity, it would retrieve some data from a data provider and apply some logic to decide or not in this exchange. The entry point converts to a DTO and returns it to the client in JSON. So the client gets 200 as ADSL capacity true, as fiber capacity true. So either ADSL or fiber to this customer in Chelsea, and have a new happy customer. Just another example. How do we test all of this? I want to talk a little bit about our testing strategy, because it's really one of the in this style of architecture. Have you seen this type of diagram before? Testing pyramid. It basically says that tests at the bottom are cheaper, the cost is low, so we can afford to have more coverage with that type of test. And higher the tests become, so we cover less and less. Well, in SNS, we are very big on doing TDD and doing pair programming, but we do TDD really all the time. Unless we have a valid reason, we action code without a failing unit test. Unit tests, we try to cover, well, aim for 100%, but get to whatever you can. We really cover, we try to cover everything. I'm going to guess that most people are familiar with what a unit test looks like. You simply mock your classes, isolate that class and test it in. What we like to say is that we treat unit tests as dev-to-dev documentation. We treat unit tests as a developer leaving documentation for a future developer or yourself in the future. Right, how I want this class to work. Hopefully, no surprise so far with TDD and unit tests. What really makes a difference is the way we do acceptance tests. So we try to do BDD as much as we can as well. Yeah. What's BDD? BDD is behavior-driven development. And it's like, whereas TDD is about documentation for developers, it's about documenting the technical aspects. Development is about documentation for the business. It's about documenting the business requirements. You might have heard of some frameworks like Cucumber, JBehave. Usually people do with those frameworks. So there are higher level tests on the business requirements. What most people have to do is that because your business requirements are across the whole application, they have to spin up the application and have tests that have to Selenium or big client and go through the full stack of your application. So you end up with builds that take minutes, half an hour. What we can do instead with this architecture is our business logic is inside core. We mock out all the entry points and data providers and test, because we know that all the business requirements are implemented in the use case. We use a framework that someone developed in SNS and then open sourced. It's called Yaspec, but you can use whatever framework you want. This one is quite nice because it converts your given some ADSL, blah, blah, blah. It becomes some HTML. So you get this nice HTML output that is stored in TeamCity and is left as business requirements. We mocked out all the dependencies. We are running a use case directly, fast as a unit test. With something that is almost as fast as a unit test, and have really, really fast builds. We can afford to go crazy with how many business requirements we can document because they're really, really fast. Leaves out the edges. We still have to test them somehow. Integration tests to test them independently in isolation. Test API, we would mock a use case, go through and just test API is doing its job. To test the database, we would run some queries directly. To test third-party systems, we would usually use zombies or contract tests. And then just to make sure that everything is wired up together and is working as expected, tiny bit of end-to-end tests that application and test a full user journey. But those are really expensive because you need to have the full application running, keep them to a minimum. Just one, we might test just the most important user journey requirement. So this is really one of the key benefits of this architecture. You get an effective testing strategy. Our production application has a build time of 2 minutes that covers everything with all those type of tests. And it's really, really nice to work on. So that solves the slow, heavy tests, effective testing pyramid. With this type of architecture, we get to isolate the frameworks. So Spring is only in the configuration. In each module, you are free to decide to use whatever you want, but then you can replace them, not easily, but it's a bit easier than if your framework was everywhere. So frameworks are now isolated. And we are independent from the database. The database is just one of the data providers. We don't design the tables first anymore. They become just a way to store something that our business logic needs to do. And this is particularly true in the way we design our REST APIs. You know how in RESTful you tend to, RESTful will let your clients send, if you want to change something, they can send you a post with a piece of JSON and change all the fields of your objects. But that feels very CRUD oriented. We don't want to do that. So we let you read everything in a RESTful style. But if you want to change something, you need to call a particular URL that we call make live, for example, and then we can apply all the logic we want and validations we need. But we don't let our clients treat us as a CRUD system. So that fixes the centered around database. We achieved at least a little bit what Unclebob calls a screaming architecture. When you open the package structure, you get an idea of what our application can do, the domain of the application rather than the technical details. So we're not so focused on technical aspects anymore. We now know that all the business logic is in the use case, so we know exactly where to go when a business analyst asks us, oh, how does this thing work? Can you change what's the impact of this change? You know exactly where to go to find business logic. All the business logic is now in the use cases. And as I was saying, because we use modules, it's hard to do the wrong thing. If you use something that you're not supposed to, it doesn't compile. It doesn't mean that you can't mess things around. Trust me, we have done a bit of mess sometimes. But it's harder. You really have to think about it. If this application was created 2 years ago and they've never needed to use Spring in this module, so why do I feel the need to add it now? It's like a safeguard for the future developers. It will make them think about, why does this not compile? And we are always ready to deploy. Yeah, sorry.
He's asking for web application. Any of the tests which are
Okay. Well, I might as well answer that now. Do you want me to repeat that? Yeah, so for a web application, would you still need Selenium tests? I guess I would. I would try to use them as little as possible, because with this type of architecture, I've already covered all my business logic, testing the use case directly, and I've covered all my data providers. And you would want to cover so I would use Selenium just for end-to-end tests in that case, just for the top of the pyramid. So use them a little bit just to test that everything is wired up together, just the most critical user journey, rather than what a lot of people do when it's through the GUI. So I would use Selenium tests just to check that the details are tested in unit tests and acceptance tests. I hope he's happy with the answer.
They can stop your back. They can stop your back end. If they're not, they get that from data perspective. It's quite hard to Selenium test things to do.
Like when you use third-party systems. Yeah. If you can do that, that would mock out the backend and test just on the technology that they're using for the GUI. That might be easier or harder.
with, I asked this, because whoever has worked in shop would find out that you end up having large integration tests that are Selenium slow, but important to be part before release.
Okay. Thank you. I can't remember his name, but I'm happy he's happy. So yeah, just to get towards the end, we're always ready to deploy because we're working on a feature is we start implementing the feature, but we don't do the configuration. So we don't wire the new objects in until everything else is working and is passing all the tests. It's some sort of feature flags, but always work on master, and sometimes we release code that has some dead code inside, but it's not doing anything. We wire it in. So these allow us to be always ready to deploy. Of course.
So if it's modifications for existing V2, and then put that live on the
Yeah, if the change is modifying an existing use case, would I create a V2 or change the existing one? Well, I guess in that case, it depends on how big the change is and when the next release is going to be. If we think we have enough time to do the change safely before the next, I would probably change that one directly. In some cases, created a V2 instead, and then migrated requests from V2 incrementally, maybe. Yeah. We just make the tests fail, then we fix them, and we're done. If it's something bigger, we would. We've done that for scheduled jobs a lot, actually. With jobs rather than changing the existing ones. And then just for one night, we run the new one instead of the old one, check if it works properly. And if we are happy, we can remove the old one and keep only the new one. Another really cool benefit that is not really technical, but made us really, really fast, is that with this architecture, we can parallelize work. We work in pairs. And what we usually do on a story is, at the beginning, do just a little bit of mob programming, just to sketch out what the use case is going to look like and define the interfaces that it needs. And then we swarm off, and a pair starts to implement the use case, a pair implements the data providers, the entry points, because everything is so independent and decoupled, allow us to work independently on all these different layers. So even complex features on this application take just a few days. And if you want to do microservices, what usually the experts on microservices tell you is, don't start with microservices. Beginning, you don't really know how to split your application into services. What I think is that this type of architecture is really good to create your initial, let's call it monolith, define very clearly what your use cases are. And after a while, when you're ready to go into microservices, and you can decide, okay, this one goes in there, this one goes in there, and you can stay in the monolith. But it's obviously not. There are some with all of this. And the most obvious one is that you will sometimes feel like you're duplicating code. An exchange object as your entity. Then if you use Hibernate, you have Hibernate object inside the data provider. And then you might have an exchange DTO to return to your client, to feel like you're doing things 3-4 times. But as long as you keep pragmatic, it doesn't really become a problem. Real need is the same object, just reuse the same object. But as soon as they start having differences, then we duplicate the objects and individual layers. But what might really put you off from doing this type of architecture is that you need to have interesting business logic. If what your application does is just system, if all it does is a single line of code saying read from a database, you need all this infrastructure of different modules and different type of tests. So you have to be honest and understand use case. Am I going to have interesting business logic to put in the use case, or will it just database? Yeah. Right, so hopefully I've showed you how we implemented this architecture and how most of these problems for us. What I would like you to remember from today as the key takeaway: the center of your application is the use cases of your application. If you focus on the use cases first, hopefully. Other resources, if you want to learn more about the subject, you can check out my example project if you want to the details of how it works together. And that's it for me. Thank you very much. questions if you have some. Yep.
On the DDD side, do you have several services like the DDD portraits, application level, infrastructure level services on your application? Because I saw you showed use case, and I think on DDD, like an application level service, like the entry point to the domain. Obviously, sometimes certain behavior doesn't belong to any entity, then you might create another service which just handles that particular domain. So do you use this kind of differentiation of service?
So the question is, do you use different types of services like services or infrastructure services?
Yeah, domain service, sorry, service.
Right, so yeah, domain services and infrastructure services. I think so. So a use case is usually focused on a particular business requirement. So that's always a domain service. Be an example of an infrastructure service.
Well, maybe having would be the database would be a kind of service. So for example, let's say you have sometimes multiple database.
Okay.
And then you have the service which is the entry point at a particular point. So then you can wire database. Because it is sometimes.
Okay. Yeah. Sometimes, yeah, maybe the use case uses one interface. It's implemented by a database that is actually running 5 queries and in order to return what the use case needs. So yeah. So have something that is only in the entry point, for example, like health check endpoints, or something like a status page to check if your application is up. Application logic, so it lives just in the entry point. Yeah. Okay.
Yeah, I was just going to ask, have you found that following this approach, it's actually easier or quicker to make changes to your application?
So the question is it quicker to make changes? Say, absolutely yes, but you have to look at the bottom line. So you might feel slower in the while still making the changes because you have a few layers to change. But because we can parallelize so much, have such high quality because of all the type of tests, in the end, we are much faster. So long run, we are much faster than working on the legacy applications that we have. There's a tiny bit of this, like when you're setting up the project, initially you have to set up the modules and configure the dependencies correctly, blah, blah, blah. Once we even put it on GitHub, so we've got the template and we use that to start.
And have you actually taken any of those applications and migrate them to microservices, or is that something you would try and do in the future? Just I'm interested to see if it's easy to actually migrate.
So the question is, have we migrated to microservices? Not really, because as I was saying, yes, this is an individual application, but it's not really a monolith. We still try to follow the ability principle. So an application still has only one business requirement, ideally. The example, for example, is based on something that we call network inventory. So its only job is to keep track of what Sky has around the exchanges, but it wouldn't do anything else. To actually reserve broadband for a customer, for example, there will be another application, and to reserve fiber, there will be another application. No, I don't. Well, unless we really need to scale it, like if we got so much customers that we need to really scale it, then we might, but it works well enough.
For me, it was just one more question about the management design. On the entities, I saw you have catalysts and setters. all the time. Do you also use value objects? Mutable? Do you have mutable entities?
The question is, do we use value objects? Yeah, sometimes, especially with the tiny types. Like instead of using string for a host name, we might create a host name type, and you can, and that would be immutable. So yeah, sometimes when we can. Yeah.
Is that this pattern seems to suggest that we should dynamic entities. So at least in the example, which is quite simple. So I don't know if the example is the intention of having entities that look, and then my business logic in this use case is that I don't know. It's the entity should solve that, but
yeah,
I would be breaking this pattern.
Okay.
So how do you
Yeah.
deal with that?
So the question is, should we put logic in the entities, or why are they so simple? Because sometimes solve a problem in the entity.
Yeah, I mean, there are design principles that say that your entities should solve a business, right?
Yeah, yeah. So are actually very simple, but sometimes we do put logic in an entity. The way that we used to decide is this logic valid, always valid for this entity, or is it related just to this particular use case? So just for what the user is trying to do right now, or is it something that is part of being an exchange? For the host name, for example, so in a device, when we might put the logic to validate that the host name follows abc.sky.com, for example. So we do put some logic in them. Logic is all use cases, so, the whole domain.
How did you start the team? Like, especially people come from deeper mindsets. This is a mindset.
Yeah. The question is, how did we start? How did we convince the team basically to follow this approach? Well, we have 2 applications doing this now. Not everybody was fully convinced, and we had to compromise a bit of a mess because of that. But example, like the people that weren't so convinced actually got on board. So we realized the value that was in it. We realized what mistakes we made. We did it a lot better, and that's what the example is based on. Yeah, we had to a couple of people to just trust us for a month or so, just to show them what it would look like.
To hire people with this mindset.
Is it difficult to hire people with this mindset? Not in SNS. I'm not sure how it works for the rest of Sky, but in the recruitment process for our department, a pair test with a candidate, we make sure they can do TDD, we make sure they like pairing. So we make sure that we hire people that will enjoy working in this style. This style of architecture is great for new people because you can tell them, okay, here is an interface, please implement it for me. They might not have the full domain knowledge yet, but at least they can be useful and do something for you without having to understand everything.
Thank you very much.
Okay. Thank you. Thank you so much for coming.